Projective Geometry, Volume 1, by Oswald Veblen and John Wesley Young.
Chapter 6, Algebra of Points and One-Dimensional Coordinate Systems. Section 53, Non-Homogeneous Coordinates. By comparing the corollaries of Theorem 1 with the definition of group, page 66, it is at once seen that the set of points of a line on which a scale has been established forms a group with respect to addition, provided the point P infinity be excluded from the set. In this group, P0 is the identity element, and the existence of an inverse for every element follows from Theorem 8. In the same way, it is seen that the set of points on a line on which a scale has been established and from which the point P infinity has been excluded forms a group with respect to multiplication, except that no inverse with respect to multiplication exists for P0. P1 is the identity element of this group, and Theorem 9 ensures the existence of an inverse for every point except P0. These considerations show that the first two conditions in the definition of a number system are satisfied by the points of a line. If the operations plus and times are identified with addition and multiplication as defined in sections 48 and 49. The third condition in the definition of a number system is also satisfied in view of Theorem 5. Finally, in view of Theorem 1, Corollary 4, and Theorem 6, this number system of points on a line is commutative with respect to both addition and multiplication. This gives then Theorem 10. The set of all points on a line on which a scale has been established and from which the point P infinity is excluded forms a field with respect to the operations of addition and multiplication previously defined. Assumptions A, E, and P. This provides a new way of regarding a point, namely that of regarding a point as a number of a number system. This conception of a point will apply to any point of a line except the one chosen as P infinity. It is desirable, however, both on account of the presence of such an exceptional point and also for other reasons, to keep the notion of point distinct from the notion of number, at least nominally. This we do by introducing a field of numbers a, b, c, l, k, x, y, z, which is isomorphic with the field of points on a line. The numbers of the number field may, as we have seen, be the points of the line, or they may be merely symbols which combine according to the conditions specified in the definition of a number system, or they may be elements defined in some way in terms of points, lines, etc. In any number system, the identity element with respect to addition is called 0 and denoted by 0, and the identity element with respect to multiplication is called 1 or unity and is denoted by 1. Footnote, see for example section 55 on von Staudt's Algebra of Throws, where the numbers are thought of as sets of 4 points. We shall, moreover, denote the numbers 1 plus 1, 1 plus 1 plus 1, 0 minus a, by the usual symbols 2, 3, minus a, In the isomorphism of our system of numbers with the set of points on a line, the point P0 must correspond to 0, the point P1 to the number 1, and in general, to every point will correspond a number except to P infinity, and to every number of the field will correspond a point. In this way, every point of the line except P infinity is labeled by a number. Footnote. Chiefly, however, in this connection, see section 57 below. This number is called the non-homogeneous coordinate of the point to which it corresponds. This enables us to express relations between points by means of equations between their coordinates. The coordinates of points, or the points themselves, when we think of them as numbers of a number system, we will denote by small letters of the alphabet, or by numerals, and we shall frequently use the phrase, the point x, in place of the longer phrase, the point whose coordinate is x. It should be noted that this representation of points of a line by numbers of a number system is not in any way dependent on the commutativity of multiplication. i.e. it holds in the general geometries for which assumption P is not assumed. Before leaving the present discussion, it seems desirable to point out that the algebra of points on a line is merely representative, under the principle of duality, of the algebra of elements of any one-dimensional primitive form. Thus, three lines, L0, L1, L infinity, of a flat pencil determine a scale in the pencil of lines, and the three planes, alpha 0, alpha 1, alpha infinity, of an axial pencil determine a scale in this pencil of planes. To each corresponds the same algebra.
Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renhold, with programming and illustration by Jim Renhold, 2019. Thank you for listening.